I'm going to explain experiment on power division and isolation of microstrip power divider. The aim of the experiment is to determine the power division and isolation characteristic of microstrip power divider. The objective of the experiment is to understand the power division and isolation characteristics of microstrip power divider. The operators required are microwave signal source with modulation ranges from 2.1 to 3 GHz, 3 dB attenuator pad, 2 to 3 GHz coaxial detector, VSWR meter, 50 ohm matched loads, 2 to 3 GHz microstrip power divider and connecting cables. This is the setup of power divider. Power divider is a 3-port device in which one input port and 2 output ports. The function of a power division network is to divide the input power into 2 or more outputs. As an equal split power divider, the power incident at port 1 gets divided equally between two ports 2 and 3. So here also you can observe the division. One equal amplitude in phase signals is fed to port 2 and 3. The device acts as a power combiner and the entire power appears at port 1. If power is fed only at port 2 or port 3, then half of the power goes to port 1 and the other half gets dissipated in the isolation resistor. In all the cases, port 2 and 3 are mutually isolated. The procedure of the experiment is: assemble the setup as shown here, measure the reference power level by connecting the cable end at P and Q directly. Set the frequency of the source 2.2 or 3 GHz and increase RF output of the source till VSWR meter reading shows in the range 45 dB. Increase the frequency of the source in steps of 0.1 GHz from 2 to 2.8 or 3 GHz and note down the corresponding reading in the VSWR meter. To measure the power division property, insert the power divider between P and Q with port 1 as input port connected to P and port 2 which acts as output port connected to port Q. Terminate port 3 of the power divider with 50 ohm matched load. Record the readings of the VSWR meter for frequencies from 2.2 to 3 GHz. Interchange the connections at port 2 and 3, that is connect port 3 to Q and port 2 to 50 ohm matched load and record the readings of the VSWR meter for the frequencies ranging from 2.2 to 3 GHz. Using calibration graph, get the corrected value. The corrected value can be recorded as P1 dash, P2 dash and P3 dash. For power division from port 1 to port 2 can be calculated as P1 dash minus P2 dash. For power division from port 1 to port 3 is calculated as P1 dash minus P3 dash. To measure the isolation, remove the power divider from the setup. insert the power divider between P and Q with 2 as input port and connect that to a port P, and port 3 as output port, connect it to a Q. Terminate port 1 using matched load 50 ohms. Record the readings of the VSWR meter for the frequencies from 2.2 to 3 GHz using the calibration graph. Get the corrected value of P1 dash and P3 dash. Isolation is calculated in dB. So isolation can be calculated as P2 dash minus P3 dash. This is the tabular column which shows the VSWR meter reading taken from 2.1 to 2.8. We can record the readings till 3 GHz. Port 1 to port 2. Record the reading. Port 3 again record the reading. P1 dash, P2 dash, P3 dash are the corrected value in the calibration graph. To record power division from port 1 to port 2, P1 dash minus P2 dash gives power division. To record the power division from port 1 to port 3, P1 dash minus P3 dash. And this is the tabular column for the calculation of isolation. Again, take the readings in the VSWR meter for the frequencies 2.1 to 2.8 or 3 GHz. Record the readings as for P2 and P3 and get the corrected values from the calibration graph, which is recorded as P2 dash and P3 dash, and the isolation can be calculated as P2 dash minus P3 dash. So this gives the isolation characteristics. The outcome of the experiment is students will understand the power division and how the isolation characteristics of the power divider are done. Now let us move on to the demo of the experiment. Let us see the demo of power division and isolation of microstrip power divider. So here again we need microwave signal source with the modulation attenuator pad, VSWR meter, transmitting antenna and receiving antenna. Here the source signal will be from 2 to 3 GHz, attenuator of 3 dB and VSWR meter with a detector. This is the power divider. In this power divider, we are going to calculate the isolation or the loss in the power. So again we are using 50 ohm matched load. This is port number 1, port number 2, port number 3. For port number 1, signal source has to be connected like this. Now for port number 1, signal source is connected, and at port number 2 I am connecting the detector part. After connecting the detector part, the signal have to be varied from the source signal. Turn on the RF, vary the signal from 2 to 3 GHz. As we vary the signal from 2 to 3 GHz, we can observe the change in the VSWR meter reading. Vary the signal source from 2 to 3 GHz. Now see the change, and you have to note down the readings. Tabulate the readings in the tabular column. Now after taking the readings, tabulating in the tabular column, power division have to be calculated. Power division has to be calculated from pin number 1 to pin number 2, and pin number 1 and pin number 2 calibrated graph readings have also to be noted down. Next, connect the same attenuator to port number 3 and repeat the reading, tabulate the reading, and finally calculate using the calibration graph. So this is the calibration graph. This is the value which we have got from the VSWR reading meeting, and this is the corrected value. So note down the corrected value in the tabular column. Finally, calculate the corrected value of the calibration graph. Thank you.